Okay, everybody, this is our last set of notes for Unit 8. Just one more reminder of how an equation, a table, and a graph can represent a word description. So we have this description. A cheetah can run 22 feet per second. If we're to fill in that table, we can see that after 1 second, that cheetah will have run 22 feet. If you give him 2 seconds, he'll have run twice that, which would be 44 feet. If you give him 3 seconds, he'll have run 3 times that, which would be 66 feet. And then, of course, if you give him 4 seconds to run, he'll run 4 times that, which would be 88 feet. So there's the table that represents that word description. We can write a graph because we know that the first part of the table has to be our x and the second part of the table equals our y. So we can write a graph, we can write an equation to go with this graph in the form of y equals, because the number of feet that cheetah has run is equal to 22 times x, the number of seconds. Please write it as that, not x times 22. Y equals 22x is our equation. Now all we have to do is come over here and graph it. And I'll remind you that if 0 seconds pass by, that cheetah will have run 0 feet. So we'll graph that on the graph even though it's not in our table. And then it's a little dicey here because our feet are going up by tens, whereas in the table they're going up by 22. So we're going to have to be a little we're going to have to do a little guesswork on our table. It won't be exact, won't be necessarily perfect. But we do know that after 1 second, that cheetah will have run 22 feet, which would be somewhere between 20 and 30, but closer to 20 on the y-axis. So we'll put our graph, our dot on our graph right there. Okay, just on the 1 for x, but a little bit above 20 on the y. And then we'll do the same thing with in 2 seconds, he'll have run 44. So that'll be less than half, but a little bit more than the 22 on the 2 on the x-axis. And then for 3 seconds, it'll be closer to 70, but not quite 70 on the y-axis. And of course, it'll be on 3 on the x-axis. And then we can keep going. In 4 seconds, it would be 88, which again would be very close to 90 here. And if we move on up, we can't go any further because the next one would be over 100, right? So that's about as far as we can graph that situation with this graph that we're given. So there you are, a word problem, a table, an equation, and a graph that all represent the same situation. Look at number 2. 8 movie tickets cost $24. Oh, 8 movie tickets cost $24, not 1 movie ticket. So if we were to try to figure out what 1 movie ticket costs, what would we do? Oh yeah, we'd divide the cost, $24, by the number of things we're buying, 8 movie tickets. Well, I know in my head that 24 divided by 8 is 3, which tells me that if I'm buying 2 tickets, that will cost me $6. If I buy 4 tickets, it will cost me $12. If I buy 6 tickets, 6 times 3 is 18. 8 tickets, 8 times 3 is 24. We already knew that. That was our given situation. And of course, if we buy 10 tickets, 10 times 3 would be 30. So this is a multiplicative relationship. And there's the words. Here's the table. Let's write the equation. We're going to always write it in the form of y equals. Later on, you'll learn different ways to write equations. But for us, for right now, we're going to write it in y equals whatever's happening to x. And here's our x. and here's our y. And we already figured out that the multiplier was 3, so y equals 3x. There's your equation. Now let's graph that. On our table, we're given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis for movie tickets, and they're going up by 10s on the price for the y-axis. So we're going to have to, again, kind of estimate where that dot's going to go, because it can't be just totally exact. But I do know that if I buy 0 tickets, it'll cost me $0. And if I buy 1 ticket, it'll cost me $3. So it looks like in between here would be 5s. So it's 10, 15, 20, 25, 30, 35. I don't have to put those numbers on there. It just helps me see what I'm doing a little better. So I went ahead and put those numbers there, so it'll help me. But if I buy 1 ticket, it costs $3. So I'm going to graph that right around here, because I cannot be exact, but I'll be close. If I buy 2 tickets, it costs me $6. I'll graph that right about here. 3 tickets, $18. I'm sorry. Yeah, 3 times 3 is 9. 3 tickets, $9. That wasn't on my table. 4 tickets, $12. 5 tickets, 5 times 3 is 15. Oh, there's one that's actually on the graph. 6 tickets, $18. 7 tickets, $21. 8 tickets, $24. 9 tickets, 9 times 3 is 27. I'll be right around here. And then 10 tickets, of course, will be $30. So you can see my graph is not perfect because I'm not great at judging those dollars amounts in between, but it's pretty close to a straight line, which it should be a straight line in this case because it's going up by 3 each time. All right, let's turn this paper over to the back if you have it. Number 3, a hummingbird can flap its wings 100 times in 4 seconds. So how many times in 1 second? Well, again, we'll divide the number of flaps by the number of seconds, or the thing that's happening by the time. 100 divided by 4 would be 25. So in 1 second, that's 25 wing flaps. In 2 seconds, 50. In 3, 75. In 4, 100. We already knew that. It was given to us here. In 5 seconds, 125. In 6 seconds, 150. And in 7 seconds, 175. So with each second that goes by, there's 25 wing flaps. So we write that as in the equation. Remember, this is your x, this is your y. Y equals 25x, 25 times the number of seconds. All right, and then we graph that. Oh, this is a little bit better and easier to graph. I can see that it's going up by 50s, but in between there would be my 25s. So I know that 1 second would be here, 25. 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. This makes a nice, neat graph because of the way it's drawn. And then finally in 10 seconds, it'll be 250 wing flaps. Bet that bird's tired. Okay, now one last example. These are all multiplicative so far, and I think this is going to be the same for the last example. A full-grown lion can eat 70 pounds of meat every 2 days. So the pounds of meat is dependent on the number of days. Days, weeks, hours, months. Time is almost always your independent variable. So if it's 70 pounds in 2 days, then we have to divide the number of pounds by 2 to figure out how many it is in 1 day. And I already know that 70 divided by 2 is 35. So that means in 1 day it's 35, and in 2 days it's 70. In 3 days it would be 35 more, or 3 times 35, which is 105. And then in 4 days it'd be 140. We write our equation. Remember, this is your y, this is your x. Always in a table, the x comes first, the y comes second. So our equation is y equals 35 pounds per day, 35x. Okay. Now finally, we'll just graph that right here. They've given us a graph already labeled to write our numbers on. So we'll put one day that lion will eat 35 pounds of meat. In 2 days, it will eat 70 pounds, somewhere between 60 and 80 on that graph. In 3 days is 105, so we'll put this kind of right here. In 4 days, it's 140. So I got pretty good on that one. It's a pretty straight line. How much will it eat in 0 days? Oh, 0 pounds. So this is a multiplicative relationship. All right, so there you go. Another reminder how to put a table, a graph, and an equation together for a word description. I hope you're having a great day. I hope I'll see you soon. Bye.